Hello and welcome back. In this lecture, we are going to try to put together all the different things that we have learnt about how to write iteration in programs, and we will try to use these things to write a couple of programs to solve some small interesting problems. So here is a quick recap of what you have already learnt so far. You have learnt about iteration idioms in programming. Specifically, you have learned about while, do while and for loops in C++. We have learnt about the usage of assignment expressions and their variants in loops, particularly in for loops, and we have also looked at how break statements can be used in loops to jump out from somewhere in the middle of the loop body. In this lecture, we will try to put all these things together to write programs with iteration to solve some small interesting problems. And we will also see a new kind of statement that comes in handy when we are trying to write programs, and we will sort of motivate the usage of this statement by one of the problems that we are going to try to solve today. And this new kind of statement is called continue statement, and it is kind of like the dual or the counterpart of the break statement, and we will see its usage and how it closely relates to the break statement in the programming problem that we are going to try to solve. Now, as our first example, let us consider this problem. Suppose you are given positive integer inputs m and n, and you are required to compute 3 raised to the minimum of m and n and 2 raised to the maximum of m and n, and you are supposed to print their values. So how would one go about solving it? It is quite straightforward. One could say, let us just take the values of m and n. Let us find out what the maximum of m and n is, what the minimum of m and n is, and then let us have a loop in which we keep multiplying 3 for min mn times, and let us have another loop in which we keep multiplying 2 max mn times. Well, so if you were to solve the problem by a program of this type, you would have 2 loops in the program. The first loop would be iterating min mn times and computing 3 raised to min mn. The second loop would be iterating max mn times and would be computing 2 raised to max mn. An interesting question is, can we write a program that actually calculates both 3 raised to min mn and 2 raised to max mn, but using just one loop in C++? So that sounds interesting, and let us see how we can go about doing that. So let us look at how a C++ program for this min-max example might look like. I have grayed out some parts of the program that I am not going to focus in the current slide, and I have written in black the parts of the program that I am going to focus on in the current slide. So we start off with our main function, which returns a value of type int. We declare some variables. So here I have a variable called min of mn, max of mn, both of which are integers initialized to 0. I also have 2 variables, 2 raised to max and 3 raised to min, both of which are initialized to 1. I of course have variables for the inputs m and n, and I have 2 counters called I and j, also of integer type. So I first ask the user to give me the value of m and n, and I read in the values of m and n, and then I create one single for loop in which, in the initialization part, I have used 2 assignment expressions separated by a comma. Recall that this becomes one compound expression in which the component expressions are evaluated from left to right, and when these assignment expressions are evaluated, as their side effect, the value of m gets assigned to the variable I, the value of n gets assigned to the variable j. So as a result of evaluating this compound expression, I have effectively initialized the values of I and j to those of m and n through side effects. What is the update expression? It is the post decrement operator applied on I and j, once again separated by comma. So once again, this is a compound update expression composed of 2 component expressions. The way this compound expression is going to be evaluated is that the component expressions will be evaluated from left to right, and these post decrement expressions, when they are evaluated as a side effect, they will effectively decrease the values of I and j. So I am going to start with the values of I and j set to m and n, and I am going to decrement them in every iteration, and I am going to check if the value of I is greater than or equal to 1 or the value of j is greater than or equal to 1. Clearly this loop is going to iterate max mn times, because as long as one of I or j which have been initialized to m and n stays greater than or equal to 1, I am going to iterate in this loop. Now since this loop is going to iterate max mn times, I might as well increment the value of max mn every time I iterate through this loop, so that at the end I do get the value of max mn. And since I have got to raise 2 to the power of max mn, I could multiply the current value of 2 raised max with 2 every time I iterate through the loop. Recall that this is one of those assignment operators, and the effect of executing this statement using this assignment operator is that 2 raised to max is multiplied by 2, and that same value is assigned to 2 raised to max again. So if this loop is executed max mn times, then 2 raised to max will have the value 2 raised to the power of max mn, exactly what we want. Now how do we calculate min mn? So this is the interesting part. So I introduce this if statement inside the for statement, where I say that if both I and j are greater than or equal to 1, then I am going to increment min mn, and I am going to raise and I am going to multiply 3 raised to min by 2 using this special assignment operator again. Now note that if both I and j are greater than or equal to 1, where I have initialized I and j to m and n, and I am decrementing them at the end of every iteration, it means that the total number of times that this statement will get executed, the increment of min mn, is exactly the minimum of m and n. The moment one of I or j becomes 0, this condition evaluates to false, this statement is no longer executed, and therefore the value of min mn does not change. So here you see I have used one for loop, but using an if statement I am basically making these two statements be repeatedly executed only min mn times, although the entire loop is being iterated max mn times. And of course after I have done this, I could print out the value of 2 raised to max and 3 raised to min, and then return 0. So this is our first example. Now here is how the entire program looks like. I have just rewritten what we have already discussed, inserted some additional comments here for better readability of the program. Now let us look at a second example, our favorite quiz marks problem. But this is a slight variant of the quiz marks problem we have seen earlier. Here we are required to read quiz 1 marks of CS101 students one at a time. Any negative marks other than -1000 will be considered as invalid and must be ignored. On the other hand, if somebody enters -1000 as the marks, then that denotes the end of the input, and once that happens, we want to compute the number of valid marks, sum, average, minimum and maximum, and print them out. So we have seen a program that does almost this, except this part, that when I read something other than -1000 but a negative marks as input, then I should treat it as invalid and ignore it. Except this, we have seen the rest of it. So let us try to see how we might write a C++ program to do this. So let us look at how the C++ program for this problem might look like. Since we have seen programs to solve various versions of this problem several times in earlier lectures, I have put most of the program in black font, and there is only a little part that I have grayed out. So let us see what the different parts are doing. The main function returns a value of type int. I have several variables that are declared here: mark, sum, count, min and max. The average could be a floating point number, so it is declared to be of type float. And now I have this one for loop, and as the initialization expression I use this compound expression, which is made up of two assignment expressions separated by a comma. So when these two assignment expressions are evaluated, as a side effect, sum gets initialized to 0, count gets initialized to 1. The loop condition is empty, which basically means that it is true, and the update expression is a post increment expression, which as a side effect increments the value of count. Inside the loop body, I ask for the marks of a student, read the marks, and if the marks is negative, I have got to do something. Otherwise, I can update the different aggregates, sum, min and max, and then go back and iterate in the loop again. And once I am done, once I have exited from the loop, then I can compute the average, print out the count of valid marks, sum, average, min and max. Now one thing to note in the computation of this average is that I have divided sum by count plus 0.0. Why did I do that? Sum is of type integer, count is of type integer. If I just said sum divided by count, that entire expression would be of type integer and I would lose the fractional part of the average. Count plus 0.0 is of type float because count is of type integer and 0.0 is a floating point constant. Therefore, this denominator becomes of type float, and now when I divide sum, which is an integer, divided by this floating point value whose value is the same as that of count, I get a floating point average. Now let us see what happens when the marks is less than 0. If the marks is not equal to minus 1000, then I want to output invalid marks and I want to somehow go back and repeat this loop because I have got to read more marks. Otherwise, if the marks is minus 1000, then I know that all the marks have been read, so I can exit the loop, compute the average and print out the different metrics. So the usage of the break statement has already been covered in an earlier lecture. This basically skips all the instructions in the body of the loop in this iteration and directly exits the loop and comes out to the next statement after the loop. Now how do we repeat the loop here? So it turns out that in C++ there is a facility to do this called a continue statement. So just like the break statement, it skips all instructions in the body of the loop in this iteration, but instead of exiting the loop, it goes back to the start of the loop and it starts the next iteration of the loop. So here you see that break and continue can be conveniently used inside this if else to ignore invalid marks and also to jump out of the loop when we have read all the marks. And of course, how do we update sum, min and max? We have already covered this in a previous lecture, but here is a recap again. We add marks to sum, and if this is the first marks I am reading, then I update min and max with marks. Otherwise, I update min and max with conditional expressions that ensure that min is the minimum marks I have seen so far, max is the maximum marks I have seen so far. So that is how our entire program looks like. So in summary, we saw examples of two C++ programming problems where we used iterative constructs with assignment expressions, and we also saw the usage of a new kind of statement called continue statement, which is the counterpart of the break statement. Thank you.